basically also all in the context of the following kind of technology triangle that we have here. So my research, I mean, this almost, at least since my postdoc, these have been the three areas that have influenced the research that I've been doing. So my background, of course, is like in information systems engineering, so distributed systems, fast systems, high performance system, lots of data processing, real-time data processing, all this is like the standard. So what's new and what always changes, or what I'm always interested in, is like new technology. So new devices, right? So smaller devices, mobile devices, wireless devices, sensor devices. So things change here all the time. And then you basically have to adapt how you process or work with this data to still have like some kind of intelligent information systems. So the last technology that I've been interested in here to add to this research triangle have been like sensor networks. And so sensor networks have advances in the computational hardware aspect, but also just like microsensors. And so the characteristics of them, they are like embedded in space, right? So they all have like all these like deployments have like a spatial component. So all the sensor data that is collected is related somehow to what's happening in this space at that time with the phenomenon or the sensors that we use to test, to monitor things, and what we basically can capture about it. So spatial information science basically is a pillar, also the other pillar that basically helps to represent this information in more like abstract ways, to not just like build like single systems for like one particular technology. All right, so all of you, I'm sure, more or less know what sensor networks are. So to just repeat shortly, what we have here is like different trends. They're all very important. So we have like really small computing platforms, tiny computing platforms. You can see them here on like on a cent, how small they are. They have a regular computer architecture, so like RAM, CPU, storage. They run on AC. They have storage capacity to them, but they're just really tiny. And what's new to them is basically they have sensors attached. And so lots of developments are going on today with like microsensors and nanosensors. So microsensors are like a thousandth of a millimeter in size, like nanosensors are like a millionth of a millimeter in size, right? So if you see where this is going, so these tiny computers and the tiny sensors are really going to be really small in the future, and they're going to be millions of them. So we have like the possibility to measure things in a completely different new temporal and spatial scale that we have not been basically able to do before. So I'm particularly interested in applying this technology to like environmental monitoring, right? So in the geographic kind of space. So if you think about like telescopes as remote sensing instruments like telescopes, so if you use this technology, it's like an environmental microscope, right? So we will be able, once this is feasible and production ready, then we will see basically processes we have not been able to observe before. Similar like in medicine or biology or something like that. Just imagine what people saw before microscopes, and then with microscopes, today we see cell levels and all kinds of activity, right? So it will be a similar development here with like these geosensor networks and networks. So today the technology is still kind of clunky and big and not robust and not pretty at all, but we have to start somewhere with trying to make this work. But there are already like applications with it for like coastal monitoring, ocean exploration, precision agriculture, habitat monitoring, and also like intelligent transportation systems. So the big impact that we have here, that we have a big shift in like in like spatial information science, at least like from where we get data from, right? In which scale we get the data from, in which density we get it, the temporal scale that we have, just the sensor itself that we have, what we can observe, which is new. And so we will basically be able to monitor and see new things and observe new processes that have not been able to basically process or to observe before, and identify events and track those events. So this will be very interesting, but this is of course more like for people who are actually going to use this technology for their specific environment or for their specific discipline. for us, from like a computer science and system engineering standpoint, basically what we want to be able to do is like to make this work, right? To not just give people like a platform that is like some hardware, but to give them a software that is like as easy to use, like set like a Mac OS. I don't want to say Windows OS, but a general purpose and easy to use and adaptable by software to what you actually want to do, right? So we have to build up like abstractions and programming interfaces and data collection interfaces and data management interfaces on these platforms to basically make them easily programmable for those people who want to use them. So we get all this information here in a rapid rate. We get it in, they're all highly localized. They are moving devices, right? So they don't just stationary, but we have moving devices. And we also have to do like ad hoc decision making in such highly dynamic environments. So these are all kind of very new challenges from like just viewing at like what kind of data do we have and what we're gonna do with it. So now we go a little bit to like, so what have we already done in this area? So these are just like a few little applications that we have. So as I said, the technology is not really that prime time today, so it's kind of really hard to deploy them and get them real data and get some real stuff done. But here I mentioned like one of the test beds, the IGATS test bed had. So we had like a sensor network deployment here in a tomato, on the tomato plant in Madison. And basically had like sensor arrays to monitor the light profile over those tomato plants over like a 4-week period. We had like vertical arrays and horizontal arrays, and basically did some kind of environmental monitoring here with those modes. I've worked with people from chemical engineering who design microsensors to track tiny quantities of gases in the air, and basically they want to see like, so how can you integrate something like that with sensor networks. All right, so that's it from like the vision to like things we're working on to some of the topics here in sensor networks. So it's all very like technology-centric, data computation-centric. So it's more on the computational sides of like the department with things. We had already like 3 conferences in geosensor networks, and so as like an increasing interest in this research area, and so I'm looking forward to like more like exciting work in this area.